Hello everyone, welcome to this session. Today I am going to discuss about how the steam is formed and what are the different types of steam and which steam is very effective, which is used in turbine to generate the electricity. Okay, first steam. Steam is generated from water and the previous phase of water is ice. In general, let's have in 1 atmosphere pressure, the water is at 0 degree Celsius. So the ice temperature must be less than 0 degree Celsius. Let's take an ice is having of minus 5 degree Celsius, and from minus 5 degree Celsius of ice, the steam, how it is going to be generated. First case, to make ice to be as a water, what should happen? What should we do? We have to heat. So the heat is supplied to the ice. So from minus 5 degree Celsius, you have to add heat. So the temperature goes on increasing. So minus 5 degree Celsius, then minus 4, minus 3, and it goes to 0 degree Celsius. So 0 degree Celsius, what is the state? What is the phase of ice? So at 0 degree Celsius, it becomes 0 degree Celsius, the ice become water, but at 0 degree Celsius, the ice is at the phase of ice itself. Okay, so 0 degree Celsius ice is always existing, and the ice at 0 degree Celsius to be converted into water at the same temperature. So it's a constant temperature process, and at the same temperature the heat is added. So this ice, the phase of ice becomes water phase. How it should be possible without changing the temperature, how the heat is supplied? That is the question here. But the heat is generated, the heat is supplied due to the latent heat of ice. It is nothing but the hidden heat. It is said as a hidden heat. So here the latent heat of ice, due to that the heat energy is added to the ice at 0 degree Celsius. So this phase of ice will be changed to the phase of water. It is also at the same temperature of 0 degree Celsius. Okay, so we are having the ice at 0 degree Celsius and water at 0 degree Celsius at the same temperature, but the ice at 0 degree Celsius is having one type of some amount of heat energy, as well as 0 degree Celsius the water is having another amount of heat energy, but even the temperature is same, the heat energy is varying. Okay, so the heat energy is higher at 0 degree Celsius at water than 0 degree Celsius at ice phase. Okay, because latent heat is added. Next, let's move on to how the water is going to be converted into the next phase called steam. Okay, now water at 0 degree Celsius. Now you just supply heat. So let's take the water at 0 degree Celsius. Then it goes on increasing, the temperature will be rising, and 20 degrees Celsius goes on 40 degrees Celsius, 60, 80. Okay, like that goes on increasing. So the water level, the temperature level of water is going on increasing, so it becomes hot water. And if it goes to 99 degrees Celsius, what happens? Still it is at hot water. Okay, the phase of water still is at the same phase only. Now it reaches 100 degrees Celsius. But at 100 degrees Celsius, it's still maintaining the same phase of water at 100 degrees Celsius. It is having more amount of heat energy at 100 degrees Celsius. So I already told the pressure is maintained at 1 atmospheric pressure. That means 1.01325 bar. At that pressure only we are concentrating this process now. But we know that at 1 atmospheric pressure, 100 degrees Celsius is the boiling point of water. At boiling point, the water tends to boil. What happens? The water tends to evaporate. That is, boiling will happen. So the water particles will be changing the phase to vapor phase, and the water to vapor phase also be done at a constant temperature only. It means at 100 degrees Celsius the water is still water, and it goes on increasing the heat energy, but the water becomes boiling and tends to have steam. Okay, but this process, water to steam up to dry steam, okay, in between you are having wet steam and dry steam. So water to this steam formation will be done at a constant temperature. Let's take at 100 degrees Celsius water, and at the same 100 degrees Celsius it becomes steam or vapor phase. Okay, up to wet steam, then dry steam. Okay, so this will happen at a constant temperature. After that, okay, after that it becomes dry. Then you have to increase, you have to supply the heat. The heat energy will be going on increasing, but at the same time from dry steam the heat energy will be going on increasing, but at the same time the temperature of the steam will be also increasing. Okay, so in this is the formation of steam, and at 100 degrees Celsius I told you water to steam formation. Here also the constant temperature is maintaining. So here the latent heat of water, latent heat of water or latent heat of steam. Here latent heat of steam, due to the latent heat of steam only this process will be happening, and that heat energy will be supplied to the water particles. So the heat energy goes on increasing. Okay, what are the different types of steam? So here we have wet steam and dry steam. Further it is classified to the super saturated or superheated steam. What is a wet steam? So wet steam is nothing but the boiling of water happens. So some amount of water particles becomes vapor state, and most of the things will have water particles. That means some portion of the water becomes vapor, remaining are water particles. That kind of steam is called wet steam. Here in wet steam one term is to be classified as dryness fraction. What is dryness fraction? So dryness fraction is nothing but it is how much amount of dry steam is generated to the total wet steam. If let's take the dryness fraction is represented by x. If x equal to, let's take a 0.1, that means nothing but 10% of the dry steam is generated, remaining 90% of steam or water particles. Okay, it contains water particles. Then it goes on increasing. Now you just add the heat. That means due to the latent heat of steam, this x value goes on increasing from 10% to 20%, 30%, 40%, 50%. If x is going on increasing, if it reaches 100%, that is x equal to 1, what happens? 100% of the steam will be dry steam, no water particles is there. That is called a dry saturated steam. At a dry saturated steam, this dryness fraction equal to 1, that is 100% of the dry steam is created. Okay, So dryness fraction occurs only in the wet steam. Okay. Next, let's move on to the superheated steam. Now, when the superheated steam is formed, let's take the same 1 atmosphere pressure. I'm telling that if it is the steam is 100 formed at 100 degrees Celsius, shall we take it as a superheated steam? How it would be? No. Okay. Superheated steam formed beyond the temperature of the boiling point. So here the temperature of the boiling point of water is 100 degrees Celsius. So at 100 degrees Celsius up to dry saturated steam only occurs. It will be there. Beyond 100 degrees Celsius if steam is formed, that means let's take the temperature of the steam is equal to 150 degrees Celsius at 1 atmosphere pressure. So the type of steam is called dry saturated steam. So whenever superheated steam, okay, superheated steam, whenever the boiling point of water is higher, the steam formed at the temperature, then the steam is called as superheated steam. Okay, and I want to tell you some little bit information now. Without mentioning the pressure, if the temperature of water, if the temperature is equal to 85 degrees Celsius, what type of steam it is? Can you guess? We can say that it is 85 degrees Celsius means it is hot water. Okay, but it will not be always. If you know the boiling point of water only, you can say whether it is converted into steam or still remaining in the water phase. Okay, so pressure is very important. Okay, if pressure is going on increasing, then the boiling point of water also increasing. Let's take if it is 2 bar. Okay, the boiling point of water may be 120 degrees Celsius. So even at 110 degrees Celsius, it is as hot water. At 120 degrees Celsius only, it starts to boiling at 2 bar. Okay, I am telling 120 degrees Celsius is the boiling point of water at 2 bar. Just name shake. Okay, so here I would like to say that without knowing the boiling point of water, we cannot say whether it is converted to steam or not. Okay, then heat energy, in which type of steam the heat energy is very high, whether it is at wet steam or dry steam or superheated steam. So wet steam, first phase is wet steam. Okay, you have a little bit of heat energy, then you are adding heat, then it goes to dry steam. So the heat energy is higher than the wet steam at the dry saturated steam. Then further increasing the heat energy and the boiling point also increasing, then you will have superheated steam. So the heat energy is higher, much higher at the superheated steam. So it is very effective to use superheated steam in the electricity purposes production. Okay, to run the turbine we need heat energy. If we have more amount of heat energy, the work done will be higher. So that work done will be converted into electricity by coupling the generator into the with the turbine. Okay, so this is the type of steam and the energy level where it is higher, and the formation of steam from ice. Okay, these are all very important. We would like to get some more problems on this steam oriented views.